Good morning, everyone. This is the lecture on conditional execution statements for CSC 232. So, before we get into that, conditional execution statements are bits of code that only run when something is either true or false. And this is actually super powerful. So if you have, up to this point, we have code that runs no matter what for every input value. And that can be still really powerful, but once you can start performing different operations on different pieces of code, you end up with a lot more ability to do a lot more. So one example is like a max function, for example. You couldn't really write a max function that returns the max of two numbers without an if-else statement. And even if you could, it wouldn't be super useful because you'd have to have a lot of code duplication. So there are two types of conditional execution statements. There's the if-else statement, and then there's the while statement. We're going to start with the if-else. It's actually the if-else. The elif is the middle operation, but the short version of it, you don't need the elif always. You don't even need the else always. You can just have the if statement, but the format is if, and then a conditional expression, something that evaluates to true or false. And then you have a block of code in here that executes when that's true. Else, this is if this if condition evaluates to false, then the else runs. And then you have this block of code. And then after you've got all the code you had, like in anything that's not part of the if else will run no matter what. So a concrete example might help. So if we've got x equals x plus 1, and then we have this if statement, if x is equal to 4, now we know x should be 2, we're going to print math is broken today. Else, we print math might be okay, and otherwise we print goodbye. Just take a moment and think of what this was going to print out, and then let's see if you're correct. Yeah, printed math might be okay and goodbye. So the reason this is math might be okay and not math is okay is because we know x is equal to or is not equal to 4, but we haven't shown in this else statement that it's equal to 2. So we know it's 1 plus 1. We don't know it's equal to 2. I mean, intuitively we all know it is, but from the program perspective, we don't know. And so that's where the elif comes in. Elif is another if statement that will be executed if this if is false. So elif stands for else if. So you've got your if with your first conditional. If this is false, then it goes to the elif, which is your second conditional. And if that's false, then it goes to the else. You can have as many elifs as you want. You could have 15 in there to catch a bunch of different cases. So now we've got the same setup, x is equal to 1 plus 1. If x is equal to 4, which we know it's not, then we'll print math is broken today. Else if x is equal to 2, which it should be, we'll print math still works. Else we print math is broken again because we know it's not equal to 2. And it really should be. And then no matter what, we print goodbye at the end because that's not indented under this else. It's in the same level of indentation as the if block. Just take a moment, think of what this is going to print out. Yep, math still works and goodbye. This goodbye is outside of the execution chain. Next, we've got while loops. While loops loop and run the code section while it's still true. So you can think of it like it's an if statement that will continue to run as long as the condition is true, as many times until the condition is false. This is actually one way you can write a common bug. It's called an infinite loop. So where you write a while statement where the condition never becomes false, that will just run forever and ever and ever and ever. You'll have to manually kill that process. So the basic format is the same as an if statement, while, and then your conditional expression, something that evaluates to true or false, and then code to run when the conditional is true, and then some code afterwards, optional. So we've got x is equal to 1, and while x modulo 5 doesn't equal 0, then x plus equals 1. So we're going to increment x by 1 each time this loop runs. So if we just think through this, when x is 1, x modulo 5 is going to be 1. When x is 2, x modulo 5 is going to be 2, etc. as x increments. until eventually we get to some number where x modulo 5 is equal to 0, and then it will exit the while loop. Now after here, we're printing the value of x. So does anyone have any guesses as to what that would be? Think about them, and then we'll show it in just a second. All right, x equals, and then x, the value of x will be 5. So this x is being updated the entire time that this is running, even though it's defined out here, and then it's being updated here as a variable. So the first time that x modulo 5 is going to be equal to 0 is going to be when x is equal to 5. Because at 4, the value of 4 modulo 5 is 4, and then 5 modulo 5 is 0. Finally, this is an example to think through for class, then we can go over it together on Monday. So write a function, convert temp, which converts the first argument temp into degrees in Fahrenheit or Celsius, depending on the second argument 2, and returns the converted temperature. Do not do any conversion if the argument 2 is invalid. Use these formulas for conversions between Celsius and Fahrenheit. So here's your standard. Times 9/5 plus 32, or minus 32, and times 5/9. So this convert temp function is going to be a bit tricky, but I think that you all can do it based off of what you have now. So this question is asking you to write a function get number, which asks the user to input a whole number that is not divisible by 7 and returns it. If the user accidentally enters a number divisible by 7, the function shall ask the user to enter a number again until the user enters a valid number. So here we have an incorrect solution, and you should figure out the bug. So the way I would go about this is just tracing through the solution line by line, thinking about it, what happens when you put in, let's say, a number 14 or 7. And then you should be able to figure that one out. And then finally, we've got writing our own version of integer division. So integer division, if you remember, is the double slash in Python. And here we're writing a version that does not use the slash, double slash, or multiplication operator. So this is a bit of a tricky use of conditionals. And then I'd be happy to go over all of these in the lab on Monday as well. Awesome. Thank you all. I'll see you on Monday.